Now we are coming to the representation of the electric arc furnace. And in case of electric arc furnace, that is the furnace, here heats charged metal by means of heat will be generated by means of electric arc. And in case of arc furnace, it will from small units to approximate 1 ton capacity used in foundries for producing the cast iron products. Means it will vary from small units to huge, means large type of furnace, electric arc furnace, and produces the melting cast iron. Okay, and about 400 ton units used for secondary steel making. Generally for steel making, secondary steel making, also we produce the 400 ton units using that electric arc furnace. What are the temperature range? The temperature industrial electric arc furnace, the temperature range generally vary from 1800 degrees centigrade, while in case of laboratory the temperature can exceed 3000 degree centigrade. And the arc furnace, means electric arc furnace, differs from induction furnaces. Here that the charged material is directly exposed to an electric arc, means here charged material, means metal scrap, will be accumulated to the electric arc furnace. Okay, and current in the furnace terminals passes through the charged material, and using electrodes the current will be passes to the particular charged material in case of electric arc furnace. And types of electric arc furnace, first one is the directed arc furnace, alternative electric arc furnace, and another is 3-phase AC electric arc furnace. Here we use the graphite electrodes, okay, for steel making. What are the construction in case of electric arc furnace? What happens? Now the furnace consists of spherical hearth, that is the spherical hearth, okay, and here cylindrical cell, we use the cylindrical type cell will be used, and here also a swing water cooled dome shape roof also there. Water cooled dome shape roof is there for cooling purpose of the electrodes. Another, the roof has 3 holes for conjugal graphite electrodes, means the roof has 3 holes is there. 3 holes is there for holding the electrodes, okay, and also for holding that electrodes clamping mechanism is there, and by that clamping mechanism we lowering the electrodes or lifting the electrodes easily using that clamping mechanism. The water cooled electrode holders, what happens now? Sometimes the water cooled electrode holders serve as a contacts for transmitting electrode current supplied by the water cooled cables. Sometimes what happens now? Water cooled electrode holders serve as a contacts of transmitting electric current supplied by the water cooled cables, that also acting. Another, the electrode and the scrap form the star connection. The electrode, that is the electrode and scrap keeping in that particular zone, that electrodes and scrap form the star connection, of the 3 phases current, and also scrap, the common scrap is present in that particular zone. Scrap is a common junction. The furnace is mounted on a tilting mechanism, means that furnace may be we tilting as per our requirement, because using the tilting position the strap hole and slag hole is there. When molten metal will be formed, that is the molten metal zone, and that is the slag zone, and using the slag hole we easily remove the slag through the slag hole, and after removing the slag, then we easily remove the molten metal through the spout. Okay, through the spore spout located on the back side of the cell. On the back side of the cell, that spout will be located, and through which we remove the molten metal easily. The charge door through which the slag hole components and alloying additives are charged. It is located at the front side of that charging door. That charging door will be situated at the front side. Okay, and also through the charging door we send the alloying elements and also additives we send to that through the charging door. Another, the charge door is also used for removing the slag. Sometimes that charging door also used for removing the slag also. What is the refractory lining of electric arc furnace? For refractory lining, we use the resin bonded magnesia carbon bricks. We use for refractory lining, we use the resin bonded magnesia carbon bricks that are used in that electric arc furnace, and that furnace also using that refractory lining also withstand the higher temperature during heating time. And when the bricks are heated, the bonding material is cooked and turns into a carbon network bonding with refractory grains, preventing wetting by the slag and protecting the lining from erosion and chemical attack of the molten metal easily in that cases. What are the operation of electric arc furnace? First, scrap is charged commonly from the furnace top. First, we scrap is charged commonly to the furnace from the top. Then, roof within the electrode is during pouring of scraps, metal scrap, we just keep the electrodes aside from the scrap. Then the scrap is arranged in charge basket and transferred to the furnace using crane or then dropped into the cell. Okay, just we keep the electrodes aside, then we keep the metal scrap to that particular furnace. Then, and in that cases, first we apply the lower voltage. Okay, and due to application of the lower voltage, actually in that cases we just slowly heated the scraps. If we giving the extra means more voltage, the extra heat will be generated. Excessive heat will be generated, that may be damage the furnace or also damage the arcs also. Once the electrodes have reached the heavy melt at the base of the furnace, then arcs are shielded by the scrap. It means it will generate the heavy melt at the base of the furnaces, then arcs are shielded by the scrap, and in that time the voltage can also increases and electrodes raised slightly. Means clamping mechanism is there. Using that clamping mechanism, we lifting the electrodes slightly. And lengthening arcs means, and also arcs will be generated between electrodes and scrap, and increase also power will be increasing to melt the scrap easily throughout the furnace. In case of melting, starts at low voltage, okay, between the electrodes and scrap. Then the arc during, in that time the arc between electrodes and scrap are unstable. So in that cases, to improve the arc stability, small pieces of the scrap are placed in the upper layer of the charge. Small scraps we placed in the upper layer of the charge, and in that time electrode descends melding the charge and penetrating into the scrap forming boards. Means when we pouring the scrap to that particular melting zone, it will descend the melting the charge, and in that time penetrating into the scrap forming boards. Means penetrating means it will generate, means it will go inside of the scrap. The molten metal means after formation of the, means after melting of the scrap, it will come towards the, means it will come towards the bottom zone of the furnace. Means here molten metal will be accumulated. When the electrodes reach the liquid bath, the arc becomes stable. Means it will generate to the liquid metal, means in that cases arc becomes stable and the voltage may be increased. Means when the molten metal becomes stable, the voltage may be stable. So electrodes are lifting. When means it will generated to the, means it will converted to the molten metal. So at that time we lifting the electrodes. Okay. Then most of the scrap, near about 80% will be melt. Temperature near about 3500 degree centigrade reach in that particular cases. Oxidizing stage, in that cases what happens? Now, excessive carbon, phosphorus, silicon, manganese oxidize. So at high temperature, at this stage, means melting stage, what happens? Now excessive carbon, phosphorus, silicon, manganese may be oxidized, and due to oxidizing, the pureness of that particular molten metal will be deteriorated. So in that cases, so gaseous oxygen may be blown into the melt for additional oxidizing. So at high temperature the melting will take place, and due to, in that cases, some oxides may be formed due to excessive carbon, phosphorus and silicon, and in that particular molten metal. What is the reducing stage? And in case of reducing stage, what we have done, now slag composed mainly lime and CF2 will be added at this stage. Means oxide will be formed, and at that particular stage we added the lime and CaF2. So due to adding of that things, the formation of the basic reducing conditions means oxidation will be reduced. So function of that slag is refining the steel from the sulfur and absorption of oxides. Means when oxide will be formed, and at that time we added that CaO and CF2. Due to addition that things, the absorption of, means it will reduces the oxide formation. Means it absorb the oxides and form as a result of oxidation. Means again oxide will not form, and the excessive oxygen dissolved in the melt during oxidizing period is removed by metallic deoxidizer, manganese, silicon, aluminum. Using that thing, the excessive oxygen dissolved in the melt during oxidizing period is removed by metallic deoxidizer. Using metallic deoxidizer and using that slag, we easily remove the oxides from that particular molten metal. Means Mn plus O, MnO, manganese oxide will be formed. Silicon plus oxide, silicon dioxide will be formed. Al, aluminium plus oxygen, it will form the aluminium dioxide, aluminum oxide will be formed. Then basic reducing slag is favorable for desulfurization. For desulfurization, what happens? Now S plus CaO, CaS plus O will be formed. Calcium sulfide will be formed. Means using that things we easily remove the sulfur and oxides from that particular molten metal. What are the advantages of the electric arc furnace? First advantages is that use of electric arc furnace steel to be made near about 100% scrap will be converted. 100% liquid metal, molten metal will be formed. Second is the use greatly reduces the energy requirement. The requirement of the energy also reduces in the electric arc furnace. Third one, while blast furnace cannot vary their production by much and can remain operation for years of time. Years at a time also, that are the main advantages in case of electric arc furnace. and also it will the generation of the molten metal easily started and also easily stopped it also in case of electric arc furnace. What are the disadvantages? What are the environmental issues affected due to electric arc furnace? First of all, enclosures to reduce high sound. High sound will be produced in case of electric arc furnace, so we use some enclosures to reduce the sound levels. Dust collector we have used for furnace of gases. Sometimes some dust will be generated. In case of electric arc furnace, we use some dust collector for collecting the dust. Another, slag production. Sometimes slag will be produced, so for removal of the slag hole is there, and it will also controlled. Cooling water is demand, means sometimes electrodes will be heated, and for cooling purpose we use the some cooling water. Habit truck traffic for carrying out the scrap materials and handling and product conduction. So in that cases, heavy traffic will be awkward in case of in that cases. Some environmental effects, some electricity generations, means that type of things also affect the environmental. Now electric arc furnace. Electric arc furnace is used. The electric are used to melt the metal. It will be above 2000 degrees centigrade we have maintained in case of electric arc furnace. Two types: direct arc heating or direct arc furnace, indirect arc heating or indirect arc furnace. We have used that two process. Now we are coming to direct arc heating. Direct arc heating consists of circular furnace, circular type furnace, and also the refractory lining is there for sustaining the higher temperature when it will convert it into molten metal. At that time higher temperature will be formed, and 3 electrodes we have used in that particular furnace. We pour the charge to the particular inside the furnace, that is the charge. Then generally charged material remaining in the form of species, in the form of scraps. Then material have to heat known as charge. And 3-phase AC current we have used for providing the electric source, that are the electrodes. In case of single phase electrodes, we have used 2 electrodes. Means some gap will be created between the electrodes and charge, means metal scrap. And due to providing the current, one arc will be generated between the scrap and electrodes. Means in between that in between zones, the gas, means the air will be ionized, means ionized column will be formed between the scrap and electrodes. And due to formation of the arc between two things, the heat will be increased, and due to increasing heat to that particular furnace, the metal scrap will be converted into molten metal. It will convert it into molten metal. And upper part of that molten metal, that is the impurities, that is called slag, and using the slag hole or through the charging door, we easily remove that particular, means it will be tilted. It will be tilted, and what charging door is there, through the charging door we remove that particular slag. Removing the slag, then on hole is the tap hole or spout is there. Through a spout we can remove the charging molten metal, and that electrodes also we can lifting or lowering easily using holding the clamping mechanism. And to control the voltage of arc transformer is used with the tapping in primary winding. we maintain the 2000 degree centigrade in case of electric arc furnace. That process is direct arc heating. Now we are coming to indirect arc heating, indirect arc furnace. The arrangement of the electrodes in that way means arc will be formed between these two electrodes, that is the refractory lining, and charge is here. In case of direct arc heating, the arc will be formed between the electrodes and charge. Here arc will be generated between these two electrodes. When we giving the current, the arc will be generated between two electrodes, and formation of the arc between two electrodes, the heat will be generated and that charge will be converted into molten metal. And after that, in that way, we tilted the furnace and we remove the slack. After removing the slack, we collect the molten metal. Main difference, indirect arc heating, the arc will be generated between the electrodes and charge, electrode in the metal scrap, and in case of indirect arc heating, the arc will be generated between that two electrodes. Indirect arc will be generated between that two electrodes. Then through the charging door, we remove the slack, then we collect the molten metal. That is the main difference between the direct arc heating and indirect arc heating.